50 using differentials. So I don't know the square root of 50, but I know the square root of 49. So then 49 plus 1, this is, I'm focusing on 49, of course, and this is the minor error from 49 to get 50, right? So this is x and this is dx. So all I have to identify is the function, find its derivative. I found x and I found dx, and all I have to do is plug them in. This is the square root of 49. This is 1 over 2, the square root of 49, and dx is 1. So this is 7. This is 1 over 14. You calculate, you get 99 over 14. And if you plug it in and find the square root of 50 to check and compare, very, very close. Actually, we did that with the calculator. So these were the numbers. So close that 3 digits, identical decimal digits. Okay. So what would you like to go back to?
It wasn't, or at least I didn't think about it at the time. But it says find an equation of a line tangent to the graph. So I know
Okay.
the tangent lines were
Right. Okay, so let's, do you have a problem or should I look for a problem?
I have a problem.
Yes, I'm ready.
It's 3e to the negative 4x.
3e to negative 4x. So
Um,
this is our f of x.
Yeah, and then it says at the point 0 or 0,3.
Very good. Let's check. Is when x is 0, is y 3?
Are you asking me that question?
Yeah, just no, anybody. I don't put anyone on the spot.
Yeah.
Of course, because e to 0 is 1, and 1 times 3 is 3. So this is indeed correct. We should trust what the book is saying, but I was just making a point just to make sure we understand. So we're asked to find the equation of the tangent to this graph that I don't even have to graph at this point. So I have y minus y1 equals the slope times x minus x1, in which I have 0 and 3. That's what is given to me. In order to find the equation of a line when I have a point, I have to use this. But I am missing a very important piece of information, the slope. So now the question is, how do I determine this? Find f prime and plug in what? Plug in, exactly. This will be the exact same thing with the slope. Okay. So here's the function. Here's the point 0, 3. I want to determine the equation of this line. Well, the slope must be f prime of 0. Because that's the point, right? If it's a different point, then it will be f prime of that x. Okay. Good. So first, let's find f prime of x. Remember, a constant times e to u. The constant e to u times
U
prime,
prime.
which is
So
negative 4.
And then you multiply negative 4 times 3.
Exactly, negative 12 e to negative 4x. Perfect. Okay. Now, only now I find f prime of 0. F prime of 0 equals negative 12. Do you all agree with negative 12?
Yeah, I agree with negative 12.
So I have to go back and just replace this by negative 12. So y minus 3 equals negative 12. X minus 0 is just x. So then y equals negative 12x plus 3. This is guaranteed to be the equation of the line that is the tangent to the graph of the given function where at 0, 3.
Wasn't as bad as I made it out.
That's fine. Awesome. Next question. Is there anything else?
I don't have a question. I don't have an example of a question, but can we do another one of what you were working with April?
Yes,
I
of
don't
course.
have the correct pages with me for the text.
Yes, okay, that's fine.
We can use 25 on 291.
291. 291.
Everyone calls me April by accident, so I keep imagining that whenever you say anything.
Really?
Yeah.
Well, April and Angel, like, they are very close.
Yeah.
Okay, I just passed. I was looking at you and I was flipping pages. So you said 291, number?
25.
Number 25. 25 is not that type
No.
in which we have to estimate.
Is it 27?
No, 25 and 27 are different. We can look at those as well. You can choose one or the other, or yeah. So no. So let's
They give us. Okay, I see what you're saying.
okay. So let's think about it. Let's say 1 divided by the square root of 99. If I'm asked to estimate this, I will write immediately approximately f of x plus f prime of x dx. This is what I will write immediately. And then I will have to identify several things. I have to identify the
Problem. The
function. I have to identify x. I have to identify dx. And of course, calculate f prime. Good. So let's identify f of x for this function. Indeed. For differentiation purposes, I will write this. It's way more convenient to differentiate x to negative 1/2 than differentiate 1 over the square root of x. And they are the same. Good. So let's find the derivative. So I have the function. Now I'm finding the derivative. So then f prime of x. Remember, we bring down the power. Subtract 1 from the power. And this ends up to be 1 over 2, the square root of x cubed. And you can see why do you go back and forth. I went to the power because it's easier to differentiate. I went back to this because it's easier to plug this in instead of a power. Okay, we have 2 more pieces of information. We have to identify x, and now we have to identify dx. What do you think x should be? Very good. Why? Because I can take the square root of 100 very easily. And then the error, or dx, would be, indeed. I still have to have the 100 minus 1 to be 99. So then this, I cannot write as the equal symbol. But continuing here, yes, I can. This is the equal symbol. So equals f of x. So this is 1 over the square root of 100. Then minus 1 over 2, the square root of 100 cubed, and times negative 1. It's basically done, but I will have to simplify it. But now let's see if we have any questions before we simplify this. Is this okay? Yes? Okay, so the first one is 1 over 10. Here, when I take the square root of 100, I get 10, but I have to cube it. So minus with minus will change into plus. So 1 over 2,000. So one more time, the square root of 100 is 10, but I have to cube that 10, so it's 1,000 times 2. The least common denominator must be 2,000. I multiply this by 200 and 201. That's it. You don't have to do anything. I don't need an approximation, but I highly recommend check. Just to make sure, right? You always should check. So we're looking at 1 divided by the square root of 99.
Very close.
And 2, it should be very close, divided by 2,000. It's extremely close. 5 decimal digits, actually, because there is a 0 here as well. Very close. Very good approximation. Good. Anything else that we would like to go back to?
Can you do 87 on page 319?
87 on 319. 87, 319, 87, 87. Yes, we did that, but let's do it again.
Yeah.
That's okay. 87, 319. Okay. Natural log f of x is natural log of 8x. Very good. So this is the first layer, the outermost function. This one is the second layer, and this one is the innermost. And we have to use the chain rule. Remember, in this situation, there is no addition or subtraction. Everything is multiplied.
That means to say natural log.
Say it again. No,
Cursive.
when I differentiate. Sorry.
What is the cursive there?
ln.
Yeah.
Sorry. My apology.
Just making sure.
So f prime of x. So if you have any difficulties, just cover this and say I'm differentiating natural log. What do I get?
1 over x.
1 over this. 1 of all this, whatever this is that I covered. So 1 over, and now I uncover it to copy it, times, now I cover this, because I'm differentiating this piece.
Over 8x.
So yes, so times 1 over 8x, but now I have to differentiate 8x, the third layer, multiplied by 8. It happens that I can simplify the 8, and the final simplified form is 1 over, we put x in front, natural log 8x.
Do we get points off if we don't simplify?
Well, I'm going to write, please simplify. Good. Anything else? Anything else? Okay, well, if you remember anything, I'll stop anytime. So maybe something will trigger your memory and you'll say, stop, I want to look at this. That's fine. Is there anything right now, or we start chapter 4? Chapter 4 is another major topic. Integration. I'm not going to explain right now what this means. This is the title of the chapter. You will understand. By the time we finish, or the first 2 sections, you'll understand what it means. But let's go with 4.1, anti-differentiation. Big word.
Are we gonna undifferentiate?
I'm sorry?
Are we gonna undifferentiate?
Correct.
I knew this was coming. Like I saw it in my dreams. I just knew it.
Good. Okay. So when we are given a function, we want to find its derivative. Why? What does the derivative of a function tell us about the function? It gives us the rate of change. It gives us the slope of the tangent line to that point, the instantaneous rate of change. It tells us whether the function is increasing or decreasing. Eventually, it can give us the critical numbers, max, min, a lot of things. So this function is also a function. This function tells us a lot about this one. Okay. Now, what if we don't know this? Unknown. But somehow we know, for example, the velocity. Let's say I have a function that is the velocity function. I'm just going to make it up. 2t cubed plus 4t minus 2. I just made it up. So somehow it was determined, maybe experimentally, who knows. I have somehow the velocity function, and we would like to determine the distance function. Well, what is the relationship between these two? Well, this is s prime of this. So basically, I am given this function, and I want to go backwards to find this function. I'm given the derivative of s, which is the velocity, but now I would like to determine this function. Is there a way of determining it? Yes. And the process is called anti-differentiation. Now, the notation is very important, and I want to talk about the notation, and then I'll come back to this problem. Notation. Given f prime of x, find f of x. That's one possibility, number one. Possibility number two. Given f of x, the notation we will be using will be uppercase f of x. Okay, again, you could say, really? Isn't that so important? Lowercase, uppercase, what's the difference between these two? Yes. Because in the fundamental theorem of calculus, the most general antiderivative is denoted by f uppercase. They mean the same thing.
We've talked about this a little before, haven't we?
A little bit. April?
So you're working your way backwards,
Correct.
and you have f prime of x. Let's just say you have that. When that was originally solved for, any constants would have been dropped. So when you're working your way backwards, how do you know that they're there?
Excellent question. I'll show you how.
Okay.
Very good question. So, here's another question before I answer yours. Do you think that there is only one function whose derivative is f prime?
No.
Infinitely many. Correct. So I'm going to get to that. And I'm going to answer your question in a minute. Okay, so now it's time for us to go back. So just keep in mind, if the problem is giving us f prime, the notation, I'm not going to deduct points on this, but it's important. So f prime of x, the notation, when I'm determining the function, I use f of x. If I'm given the function, which is basically the derivative, I will be determining uppercase f of x. Okay, so coming back to our simple example here, we are given the velocity 2t cubed plus 4t minus 2, and we want to find s of t. Now, we remember that when we differentiate x to the nth power, what do we get? Times x to? Excellent. Perfect. But now, I want to determine the function here. I want to determine this, whose antiderivative, so going backwards, how do I show you without using a certain notation? I don't want to use it just yet. So I want to get an answer of t to the third. I want this prime to be t to the third.
Isn't it x over m to the m plus 1?
Correct. So this will be t to the fourth power over 4. So if I want to get x to the nth power, then I have x to n plus 1 divided by n plus 1 prime. We'll do this one more time together. Don't worry about it. You'll understand it in a blink. In a blink. Let me show you why this happens. Okay, ready? So forget about the answer. Let's differentiate t to the fourth over 4. What will you do?
You have to use the
You will bring down, no, because this is not a function.
It's not a function, that's fine.
It's just one number.
Okay.
So we bring 4 down, which simplifies with 4 in the denominator. And what do we get? T to the third. Let's say this one. We bring down n plus 1, which simplifies with n plus 1. And what do we end up having? Right? X to the nth power. So coming back to our example. So S of t, 2 stays outside, right? So what function prime, what function differentiated will be t to the third? T to the fourth over 4. T to the fourth over 4 plus 4. Use the same property and tell me what to write for which function prime will be t. So if I want this to be power 1, what should this be? If this is 1,
0.
what should this be? If n is 1, what should the power be here?
0.
How much is 1 plus 1?
2.
So we bring down 2, and we get x1, x to the first power. So this is t squared over 2. Minus, which function prime, minus 2, which function prime is 1? Correct. In this case, t. Perfect. So plus a constant c. What can the constant be? We're going to do this again in a minute. Very simple. We're going to do this in a minute with many examples. So what could the constant be? You name it. Anything. It is guaranteed, or we're going to show in a minute, it is guaranteed that the derivative of this function will always be 2t cubed plus 4t minus 2. So let's write it one more time. I'm going to write it here. S of t is t to the fourth over 2 plus 2t squared minus 2t plus c. This is my claim. And I think that this will answer April's question in a minute. My claim is that the function or family of functions, because c can be anything, when you differentiate this, you will definitely get v of t. Let's do it. Let's differentiate this function. Tell me what to write.
2t to the
Yes, you bring 4 down and you simplify. Very good. 2t to the third plus.
4t.
Very good. Minus 2t to the third plus 4t minus 2. Let's practice a few, and then we'll come back to something else.
So in our ST, what is the plus c?
Oh, because when you differentiate, this will be 0.
Oh.
The point I'm making is that this is the most general, it's called. So S of t, t to the 4th divided by 2 plus 2t squared minus 2t plus c is the most general antiderivative of v of t. It's not a specific one. It's all of them. Every possibility. When c is 0, when c is 1, when c is 2, when c is -3, when c is 0.5. Okay, let's look at another example. I don't like the notation that they use already. I have to make up an example. I'm not going into the notation just yet. Okay, ready? So let's say I want a function. I'm given a function that is 2e to the x plus 5x squared minus 1 over x. We're asked to find the most general antiderivative. If you remember the notation a minute ago, I'm not given f prime, I'm given a function, and I'm asked to find the function whose derivative is this, or the family of functions whose derivative would be that. Ready? So my question now is, 2 is 2. What function prime is e to the x?
E to the x.
Good, awesome. Plus 5 is outside. What function prime is x squared?
X to the third.
Over? Yes. X to the third over 3. Let's try. When you differentiate this, you bring 3 in front, you simplify, and you get x squared.
Oh, okay.
I have to use x to n plus 1 over n plus 1, where in this case n is 2. 2 plus 1, 2 plus 1. Minus. Then after that, it's going to be plus a constant c. Now let's think carefully. Which function I differentiate and get 1 over x? There is only one function. Thank you. However, it could be positive or negative x. So that's why we have to use the absolute value. It is guaranteed that if you differentiate this, you will get that. If you need to check, we can. I'm going to make up another one. Any questions on this? Okay.
Are you always going to have plus a constant?
If I'm asked to find the most general antiderivative. Otherwise, it's a very good question. Otherwise, is that what you're asking about? What happened with the constants, right? Okay. So, very good question, Chloe. There are situations in which I will not be asked for the most general antiderivative, but I have to be given a condition that will, like when x is 5, y is 3, that will allow us to find the constant.
Okay.
And that will be, the answer will be, to the problem will be this. Here is the only function whose derivative is that and also complies with a given condition.
Okay.
Whatever.
Okay.
Good. It's a very good question. And I want to do a problem like that. Thank you for asking. On page 379, let's look at 54. Very good question. 54, 379. We are given f of x. No, they are giving us f prime equals 6x squared minus 4x plus 2. And we are told f of 1 is 9. So, specifically, they're telling us, find a function. And you will find only one, because only one will also comply with a given condition. Not a family of functions for any c.
Okay.
This is a condition that allows us to determine that particular c.
Right.
Perfect. Okay, so let's find f of x. So f of x, can anyone dictate? Of course, 6 has to stay outside.
And you have x squared to the third. Over
Very good. Minus. We'll simplify later, but we want to see, for everyone to see. Minus 4.
plus 9.
X squared over 2. So I need to determine a function whose derivative is x.
Oh,
So this is power 1. Power 1 plus 1 divided by 1 plus 1. Plus, which function prime is 2?
C.
2x.
Oh.
When I differentiate 2x, I will get 2. Is that clear? And then plus,
C.
exactly, plus a constant c. Let's do this one more time and make sure this is clear, right? When you differentiate this, you will bring 3 in front, you will simplify, and you will get x squared. When you differentiate this, you bring 2 in front, you simplify, and you get 4x, negative 4x. When you differentiate this, you get 2. When you differentiate this, you get 0. Is this okay? Perfect. Okay, now I'll simplify a little bit. So this is f of x, of course 6 and 3, so 2x cubed minus 2x squared plus 2x plus c. And I am told that f of 1 is 9. How much is f of 1? 2 minus 2 plus 2 plus c. 2 plus c equals 9. Therefore, I know c must be 7. So there is only one function because this was given to us. 2x cubed minus 2x squared plus 2x plus 7. And this is the only function. Any questions on this? Any questions? Should we look at another?
Yeah.
Perfect. Okay, so let's look at 52. Same page, 379. 8x squared plus 4x, f prime of x, 8x squared plus 4x minus 2. And we are given f of 0 is 6. When you are ready, please tell me what to write for f.
8x third over the third over 3 plus 4x squared over 2 minus 2x plus c.
Excellent. Do we all agree with this?
Yes.
Perfect. I'll simplify it a little bit. I'll write 8/3 x cubed plus 2x squared minus 2x plus c. But now I have f of 0. Can anyone give us f of 0? How much is f of 0? C. 0, 0, 0, c. So then c equals 6. So now this is the only one. 8/3 x cubed plus 2x squared minus 2x plus 6 is the only one. I'd like to look at a word problem. Total cost from marginal cost, 62 on 379. And then I'll explain the notation we will be using moving forward. But not before I explain what it is. I cannot just, okay. So we have, let's read the problem, but let me copy the marginal cost, x cubed minus 2x. Okay, let's read it. And of course I copied something else from a different problem. So 62 has x cubed minus x, not 2x. Sorry. Okay, 62. Total cost from marginal. Okay. Solid rock industries determines that the marginal cost C prime of producing the X climbing harness is given by. So we have. Find the total cost function, assuming that C of X is in dollars and that fixed costs are 6,500. So C of X in dollars and fixed costs 6,500. Now this is the given side information. They're asking us to find the cost function. So somehow they determined the marginal cost, but they want us to find the total cost function. How do I determine the cost function from the marginal cost?
X. So the 4 over 4.
Minus?
2x, minus 1x.
X squared over 2.
Very good. Plus?
C.
Very good. Is that clear?
Yes.
If you have any doubts, bring down 4 when you differentiate, you get x cubed, you simplify, bring down 2, you simplify, you get x, and differentiate c, and you get 0. So far, so good? Okay. Now, what is this piece of information? We are told that the fixed costs are 6,500. So the fixed costs mean just turning on the light. We're not producing anything. So when we produce 0, we still have 6,500.
Is that C? Do you have to subtract that?
You mean this one?
No, F of C with it being 6,500 because that's your fixed cost.
No. When we manufacture 0 units,
Or negative 6,500.
comma, no, the cost. It's the cost function. We're not talking about Yes.
Okay.
Yeah, it's the cost function, everything is positive cost. It's negative for us, but it's positive cost. Very good point.
I'm in baking, so it's backwards.
Correct, right. So this point is really 0, 6,500. When we manufacture nothing, we still have operating costs. This point will help us do what? Determine C. But when x is 0, how much is C then? That's it. It's the only piece that does not depend on x, right? So then the cost function is indeed x to the 4th over 4 minus x squared over 2 plus 6,500. And this is the only one. Any questions? Any questions? Okay, they already in this section throw something at us which should not be here right away. Okay, so let's talk about it. Four point 2. Anti-derivatives.